Find the directional derivative of f of xy, x squared y cubed minus 4y at 2, 1. V equals 2i hat plus 5j hat. The first thing I want to do is convert v to a unit vector. And so how do we do that? We take the magnitude. We need the magnitude of v, and that's going to be our vector 2i hat plus 5j hat divided by the magnitude. Essentially comes from the Pythagorean theorem. This is 2i hat plus 5j hat, and this is v. So the magnitude of v is going to be squared, 2 squared plus 5 squared. So then the magnitude of v is going to be the square root of 2 squared plus 5 squared, which is the square root of 4 plus 25, which is the square root of 29. So this is our magnitude right here, which I'm going to divide for each unit vector, and that's going to be 2 over root 29 I hat plus 5 over root 29 j hat. And that is our unit vector, which we're going to call u. We need to take the partial derivatives of this function. So we're going to take the partial derivative of the function with respect to x. So that's going to be, right? So to take the partial derivatives, you treat whatever variable you're not looking at as a constant. So with respect to x, we're going to treat y as a constant. So we're going to say 2x times y cubed. And then for partial derivative y of f with respect to y, now we're treating x as a constant. So that's going to be 3xy squared minus 4. So the gradient as a vector, we're going to have 2xy cubed I hat plus 3y squared minus 4j hat. So let's solve for the gradient at the point. What point is it at? 2, 1. So we can go ahead and compute this out. A little bit of arithmetic here. 2 minus 1 cubed. This should be minus 4 I hat for this gradient. So 3 times 12 minus 9 is 8 j hat. Minus 4 I hat plus 8 j hat. Great, so now we have everything we need. We have our unit vector here, and we have our gradient and here. All we have to do is take the dot product of these two vectors. So the dot product of f dotted with u is going to look like our vectors. Let's just put them like this. I know I'm mixing notation. I shouldn't do that. Stick to one notation. Dotted with the unit vectors 2 over root 29, 5 over root 29. All we have to do is take the dot product. Just do that. Negative 4 times 2 is negative 8 over root 29 plus 40 over root 29. So we have 32 over root 29 as our final answer. And we are good. Let me just write that a little bit better. So that was the directional derivative, folks. Alright, I'm going to